Good evening, everybody. It's office hours time again. New backdrop tonight. All I've done is I've flipped where I'm sitting at the dining table. I'd love to say there was a lot of thought put into this, but basically there was too much junk on one half of the table, and I just could not be bothered cleaning it up. So I just flipped the camera around, did a bit of adjustments to the lighting, and yeah, so we're sitting on this side of the dining table tonight. Yes, my dining table is my office and eating area and everything else, but that's the joy of living in an apartment. So sing out in the chat line if you can't see me or hear me, the normal kind of stuff. In fact, can someone just throw something on the chat just to make sure I've enabled it for everyone? Even if it's just a hello or something, just to make sure that it's working. Let me bring up my chat window here. Anybody, can anyone chat on me? Yep, fantastic, that's all I need to know. Let's a lot of things to cover tonight. As always, let me share my screen and we'll get into it. Bear with me. Okay, so hopefully you can still see me. Hopefully you can also see my screens, etc. If not, once again, sing out. But let's get into it. As always, getting in touch is easy. Probably my Twitter handle is probably the easiest way. My DMs are always open. But all the other social media channels, LinkedIn, Instagram, Facebook, podcast, Mastodon, Counter Social, Blue Sky, blog, YouTube channel, TikTok, it's insane nowadays. You can get to them all through linktree/Connor. Just scan the QR code with my ugly mug on it, and that'll get you to all the ways, whatever your preferred method of social media is, that you can get in touch with me. As I always say, if this is your first office hours with me, when I say do not adjust your set, you'll see most of the slide content normally appears slightly skewed off to the left or slightly downwards. This is because we turn this into a YouTube video, and as you know, there's nothing more annoying than having the speaker's head covering some of the slide content, those important nuggets that you are after. So we do it this way such that when it comes into a video for your viewing pleasure later, then you'll be fine. You'll be able to just basically see all the content. I always like starting with some bits and pieces based on my background as being a huge fan of user groups and community-based events, because I think that's how we all prosper and be more successful as Oracle customers. Word of warning, two things. One is it's a month before winter here in Australia, and today was 35 degrees. That's like 92 if you're in the Fahrenheit scale. That's insane. There's no way it should be that hot. I turn the aircon off in my house when we're doing office hours, because otherwise there's this annoying hum in the background. So yes, as the night goes on, you'll see me get more and more, let's just say, glowing. I'll have a nice sheen to me. So apologies in advance. Yeah, but I like having the aircon off, so the sound is reasonable. Second thing is, if any of the demos don't work tonight, they've been a little bit rushed. A couple of days ago, my son fell over in basketball. He actually got taken out by someone and broke both wrists. And so, yeah, so it's been an interesting few days. It's like returning to looking after an infant. So, yeah, so been a little bit distracted for the last few days, but hopefully the demos will still run, but please bear with me if they do not. So what are some of the coolest things that have been happening of late? Number one is VS Code, the number one IDE development environment on the planet for Java, JavaScript, pretty much any language. We have a SQL developer extension now for it. The reason I put this up last month as well, and I'm sure most people have given it a go. The reason I threw it up again this month is just recently Jeff and Chris did a full YouTube video walking through the product, going through some of the features, some of the things and the roadmap of stuff that's coming. So I put the YouTube link down there below. So catch up with that. It's a sort of, I think about a 45-minute session, just walking through all the really cool things in the VS Code SQL Developer extension. So what's been happening in the last month and what's been coming up? Number one is Cloud World Tour has been going around all over the world. You can see these ones are now concluded, but if you are unable to get to the ones in your local region, most of the keynotes were recorded and are available in the local language. And as you can see, we've still got effectively Tokyo, which I think is today. Tokyo might be today, yep. And Mexico, I think, next week. So if you're in Japan and watching office hours, welcome along. But if you're in Mexico, then yeah, effectively, once again, 2 events, and also digital passes, which are free, are available. So you can actually watch the keynotes if they align to your time zone. Couple of things coming up. Apex Connect in a few weeks' time. I was down as a speaker for that, but some circumstances intervened, so I could no longer go there. But Fantastic Apex event, normally 200 to 300 people. If you're in Europe, try get along to that. What else is coming up? We've got the Romanian Oracle user group. Marilla runs that. Very active community member, runs a fantastic event. Call for papers might be still open, might have just closed, but if you're in Romania, and I know there's a lot of people in Oracle Romania, even Oracle employees, try get along to that event as well. What else we got? You may have seen in conjunction with the Cloud World Tour, these things called Oracle Dev Live, which is a similar kind of style of event, but focused more at the developer side of things in the Oracle database. So lots of cool developer technologies, Kubernetes, etc. So if you're more of a developer focus, then check out the Dev Live events. There's one in New York coming up, and they'll be continuing on, I think, throughout the year. Just a sort of a shift away from more the traditional Cloud World style conference to more developer focused events, more hands-on labs. So yeah, BYO laptop and get into them. What else we got? The Polish Oracle user group, the call for papers is open. I went to this event last year. Fantastic event, and I like the style of this event. This is an event that's obsessed with growth. It's just, let's find a good, solid number of community members with a common passion in the Oracle database and run an event of that scale. So typically 150 to 200 people. These aren't people trying to make the conference bigger and more scalable every year. They're just trying to make it a better event every single year. So kudos to Kamel and Louisa. They do a fantastic event. So call for papers is open. I'm hoping to get there again this year and would love to see you there. Couple of things for me, not for me, sorry, the Norwegian Oracle user group. Once again, I went there last year, couldn't make it this year. Well, I'll explain why in a second. So the agenda's just come out for that. If you go to that website, you can see the agenda, enormous amount of tracks and papers going on. So that's bigger and better than last year. So if you're in Norway or anywhere in Scandinavia, try get along to that one. This is why I can't go to the Norwegian event this year. I'll be at the the GIDS, Global International Developer Summit in Bangalore or Bengaluru next week. So if you're in India, please get along to that. In Bangalore, please get along to that. Come say hi. I'd love to see you there. And also Kscope. I've managed to get approval for travel to Kscope. So, and the Kscope committee chose some of my papers. So thrilled to be going to Kscope. That'll be in Nashville in July. And rest assured, because I'm going to that, I'll be banging that drum in future office hours up until July. So lots of cool stuff. As I always say, the reason I like to spend 5 or 10 minutes on this is, I think, the way we survive, the reason I like having office hours, but also the reason I like effectively having any kind of thing where we have interaction is support your local user groups. That is, how we prosper, how we succeed, and how we thrive. So I've got some Oracle ones there. I've got some user group ones there. Get along, be a part of your community, be active, and I think we all will be the better off for it. So, what have we got to talk about tonight? We've got object dependency mode, 23 audit not exists. What is an ETAG? A feature coming in Oracle 23. The future partitions tablespace dilemma, how to handle leap years, people migrating from a 4K to 8K block size, and the if not exists function in 23C. So a bit of a mixed bag between current technology and 23C stuff, but lots of goodies to get through. As always, if you have any questions or chats, just throw them on the chat line, and we'll be happy to basically make it a bit more interactive. So let's get going. Object dependency mode. Here's the question that came in. In the development guide for signature dependency mode, changing the data type of a parameter to another data type in the same class does not change the signature, but changing the data type to a data type in another class does. And the theory there is if you're not changing things, not changing the signature, then you might change, for example, a number to a decimal or a number to an integer, and that shouldn't change the actual validity of that procedure. But the person has said, but my dependent object always gets marked invalid, even with something like number to integer, even if they're using the dependency mode of signature, are the docs incorrect? So it really depends on where you are in a database, and that sounds a bit cryptic, so I thought I'd explain with a demo as to where this person may have misconstrued the meanings of the documentation, and also to explain the understanding of the dependency mode parameter and how it applies to PLSQL when you change the parameters, because obviously if you change the parameters, that can obviously make other things that are dependent on it invalid, which is something we normally try to avoid. So let's jump into a demo and see how we go. Let's see if I can type. Let's see, here we go. So I'm going to start with the default, and out of the box, the remote dependencies mode in your database is normally set to timestamp, which simply means every time you make a change to something, which means you've changed its DDL timestamp, things that depend on it are going to be marked as needing recompilation, and we can explore that. I'm going to create a procedure here called referenced procedure. It's a procedure that's going to be referenced by something else, and we can see the parameter in value is number. It's a number data type. And as you can see, it doesn't do anything. It just does a DBMS output line to actually spit out the fact that it was called. Here's a dependent procedure, one that basically referenced the other procedure. So dependent procedure is it calls referenced procedure. So we have this dependency between the two now. Dependent procedure relies on the reference procedure in order to work. And at the moment, reference procedure takes a parameter of type number. So what I'm going to do is, if I look at the dependent procedure, it currently is obviously valid, it compiled fine. But then I go change the referenced procedure. Now all I've done is change the parameter from a number to an integer. That is a parameter change in the same data type class. Number and integer effectively coexist as subtypes of the type of number. So based on those documentation, we would imagine that the dependent procedure shouldn't be marked as invalid because we haven't changed the data type class. And if I have a look, it seems to conflict with the docs. It says, actually no, dependent procedure has been marked as invalid, which means it will need to be recompiled. So maybe this is all about not the timestamp, it's all about the signature. Obviously, the fact that I changed the procedure and recompiled it means the timestamp changed, and maybe that's why it's been made invalid. So maybe this is the fix. Maybe this is what the docs are alluding to. What I'll do is I'll change my dependency mode to signature, and therefore when I do change from number to integer, things shouldn't change. So I'll recreate my procedure as number, back as it was before, and recreate my dependent procedure as calling the reference procedure. If I look at this, my dependent procedure is valid, as I'd expect, and now I'm going to change it, this time once again to the same data type class, from number to integer, but this time my remote dependencies procedure, or my remote dependencies parameter, is set to signature. So let's see if that changes it. And it doesn't. My procedure still got marked as invalid. So what's going on here? And as I alluded to, it depends on where you are. This parameter, remote dependencies mode. Well, the key word there is the remote. This facility, timestamp versus signature, only is relevant when you're going across databases. So let's now connect to a remote database. Took a while to connect. That's my 19C database running up on a cloud somewhere. Here's my reference procedure. I connect back to my local database, and I now create my dependent procedure, which calls this remote procedure. And we can see that's been created. If I look, it's valid. So to continue the demo now, but now we're going across databases. So I'm going to connect back to my cloud database, my 19C one, and recompile a procedure as integer. So once again, I've changed the class. If I connect back to my local database, you can see the procedure has remained valid. So this is a cool thing in the sense that it hasn't been marked invalid. And the reason for this is not necessarily about dependency modes. This is by having this on my local database, it has no vision. It has no visibility that I went over to my remote database and had to play with things. It doesn't know. It's only going to know when I try to execute it. Now, I didn't display it here, but my remote dependencies mode is back to its default of timestamp. So when I try run my dependent procedure, it blows up. This is what the default of remote dependencies mode of timestamp means. I've tried to call my remote procedure. It was changed without my knowledge, but now that I've seen that the timestamp has changed, I say, nope, something's wrong here. We need to make a fix. So out of the box, when your remote dependencies mode is timestamp and you're making changes across databases, not within the same database, yes, my procedure stayed valid, but I get this error on the next invocation. So let's see if we can improve this. I go back to my 19C database, my remote database, and I'll create the procedure back as number, so it's back to its original form, and create my dependent procedure calling the reference procedure across the database link. You can see it's valid, and I can execute it, and it runs fine. But now I'm going to go back to my remote database. I'm going to change it to a data type of another data type, but in the same data type class from number to integer. My local database still says it's valid, just like it did before, but now I'm going to change my remote dependencies mode to signature. So I've changed the remote procedure from number to integer as a parameter, but I've set this to signature. Let's see if the docs are right. Let's see if the docs say that that data type change is not big enough a change to stop you from running the routine. So we give it a run. Do I get the error? I do not. So that's where the documentation is relevant here. If I've made a change, let me go back to my slides. If I've made a change, so I put it here, yeah. It is all about being a remote dependency mode. If I've made a change to a remote procedure and remote dependency mode is set to signature, and the change in the parameters or the signature of that procedure is in the same data type class, varchar to char, number to integer, etc., then I'm not going to get an error when I next invoke that procedure, which is cool because we don't like errors when we invoke them. So hope that explains what the documentation is like and why, if you're running it all in its own database, it doesn't really apply. This is only for procedures that you're running remotely, procedures you're running across database links. So hopefully it explains that one for you. Okay, let's talk about ETAG. Here's the question that came in. I've been playing with JSON duality in 23C free. Fantastic, I'm glad you have been. I noticed that my JSON documents all come out with a tag called ETAG. What is the purpose of this field and can I remove it? So to answer the last part, no, you can't really remove it, and that's a good reason. And let me talk about the ETAG, what it is, in the reference of JSON duality views, and then we'll expand upon that to explain why I think ETAG, which is sort of flown under the radar a bit when it comes to 23C, is going to be an absolute game changer. You are going to love the ETAG in all sorts of ways, even if you never use JSON duality views. Let's explore the demo to see why this is a very cool feature. If you haven't seen 23C and JSON duality views, this is the ability to take a set of relational data, in this case I'm just taking the employee table, and expose it as a JSON document. So you can see the syntax here is create JSON duality view. I've called it emp.js for JSON. And we got this sort of graph style syntax where I'm saying take these 4 columns and expose them as JSON. So you're probably saying, well, big deal. I've always been able to take any relational data and expose it as a view. Let me make a subtle change to that definition to see why it's pretty impressive. See line 11 there. Line 11 says you can also do it with update, insert, or delete. Yes, this is a really cool feature where if you're a relational developer, you can deal with the employee table or a collection of tables solely as a relational construct, if you're an Apex developer, etc. But if I'm a JavaScript developer and I only deal with JSON documents, then I can get JSON back from the database, even though it's relational under the covers, but it just comes back to me as JSON. I can send JSON back, and I never even knew that the actual single source of truth was a relational database under the covers. To give you some examples, this JSON view, JSON duality view, just has a single column called data. If I was to query it, you can see for employee 7369, I don't get the relational data back. I just get JSON back. So if I'm a JavaScript person, I would simply send a request over like a get or a put over a REST call, and I'd get JSON back. I can pretty that up a bit so we can see it in our demos here using JSON serialize, and you can see it's now been nicely formatted. But here's where the ETAG concept comes in. Notice my definition was just 4 columns, the employee number, e-name, hire date, salary, etc. But my JSON document has a metadata sort of tag inside it. It's got things like this ETAG and this as of. And we're just going to focus on the ETAG tonight. So if I do an update to my relational data, and this is the beauty of JSON duality views, if I update my relational data, it's immediately reflected in the JSON fragment. So we can see here I changed my salary, I added $99 to a salary for this employee number, and you can see in the JSON there, the salary went from 800 to 899. It's a dual-way street. Similarly, if I insert a JSON document into the database, even though there is no JSON data store, in this case, I'm creating an employee called 8000, which is employee Connor, it's immediately reflected in the relational structures. It's a bi-directional data exchange. This is absolutely super cool, one of the headline features of 23C. So let's come back to the ETAG concept though. How does this relate? Well, let's do an update where I replace all the data as if I'm a JavaScript developer. So I'm simply sending in for a given employee, here's the replacement JSON. So I've sent in that JSON document we just saw, the ETAG, the as of, and the ID, ename, salary, hire date, etc. That all goes into my JSON document and therefore gets into the relational data stores as well. That makes a change. If I query that data coming out, you can see, yes, I've made a change to the relational data as I expected. If I query the JSON version of that same data, the data comes out, but notice the ETAG has changed. The ETAG is a way of handling concurrency with your JSON documents, something that you'd normally have to do totally by yourself. Because if I came back again and then tried to update that same row with my original ETAG, effectively think about someone's got some stale data on their screen, they go, yep, I want to send that off to the database. If I try to do it again using the old ETAG, the DFE instead of that's the updated ETAG, that's the old ETAG, I get this error. You cannot update the JSON duality view. The ETAG gives you inbuilt concurrency control management on the data. No more of these things of adding your own row versions to tables or having last updated timestamps, stuff like that. The ETAG in the JSON duality view lets you manage concurrency automatically. If you send back a stale ETAG, the database automatically does that row management for you. That's super cool. However, I've spoken about this before in terms of JSON duality, and people have perhaps interpreted this as well because it's this thing that's being inserted into the JSON that it's only relevant to JSON duality views. Well, let's have a look at this then. If I roll it all back, let's create a table which has nothing to do with JSON duality. It's just a table with C1, C2, etc. We've got dates, integers, timestamps, XML types, JSON, plobs, blobs, all the typical data types you might find inside a table. I'm going to add some rows in there. So I've got some sample rows for all the different data types. I've got an integer, a date, a timestamp. I was just lazy, I put sysdate in there again. But I've got an XML type, some JSON, etc. Here's the cool thing. The ETAG functionality that comes in JSON duality views is also exposed to us as developers in the relational side of things using this new function sysrow ETAG. If I do sysrow ETAG on column C1, which was an integer, hence my use of the alias there, I get this value back. So in the same way that the JSON duality view is using ETAG as some sort of special modification value for whether you got stale data, you can do the same thing in your own applications. So if I was querying C1 back, and then I was going to go update the table and put that data back in later on, I can use sysrow ETAG to make sure I haven't I'm not pushing back stale data into the table. So in this case, I can do sysrow ETAG on an integer column. I can do sysrow ETAG on any number of columns. So C1, C2, that's an integer and a date. It doesn't care about the data types in the main. So even for a combination of two columns, I can get a single ETAG back. It doesn't matter the order. If I do C2, C1 or C1, C2, you can see the ETAG that comes back is the same. So I don't need to worry about how am I deriving this ETAG. I can just put in all the columns I require that define to me whether a row is going to be marked as stale when it comes to the database. You can see if I've got an integer, a date, and a timestamp with time zone, I can just throw them all in there and I get an ETAG as well. Where things start to get a little bit complicated is if you have more complicated data types. So if I have an XML type, which was column C4, that's an illegal column data type to use in an ETAG. I don't see that as a really big drama because I would imagine if you're querying XML types back, you would hope there are other columns in that table that are basically going to define whether the data is stale or not when it's been brought back to your screen or has been updated by someone else. The XML type normally represents a whole stack of unstructured data that goes along for the ride, so to speak, but is one of the limitations there. You can't use XML type. However, you can use JSON. And as we know, JSON is the the successor to XML, for lack of a better term. And so yeah, if you have a JSON type, then you can use that in an ETAG as well. If you've got, for example, a combination of integer, dates, timestamps, JSON data types, all those things can be passed into a single ETAG call to get a single ETAG back. No more. The most common one I've seen typically is people used to have a row version column that they would populate with a trigger on their tables. All that pretty much can go away now. Other people have used row SCN in the past, but that has some special nuances you have to be very careful with, whereas ETAG is going to hopefully solve all these issues. Similarly, clobs and blobs. C6 and C7 were clob and blob columns. So even big, unwieldy data types like clobs and blobs, you can just throw them straight into this sysrow ETAG function, and they're going to handle that management of coming up with a single value which tells you whether when you go to put the data back, it's been updated by someone else at the same time. So super cool. So that pretty much leaves me with that XML type. And I was having just a tinker here to see if I could work around it. What if I go get the clob value out of it? Just the clob value, not the XML type itself, and try use ETAG on that? You can't do it. And the reason that is the case is sysrow ETAG is a special function. Even if I try to do something like this, C1, which was just a number, concatenated to a simple string, I can't do it. Sysrow ETAG takes columns. It doesn't take just random characters, random expressions. It takes columns. It has a special purpose. Its special purpose is to take columns from a table, come up with a single value that represents all the data in those columns you've provided, such that when you go back to the database, you'll know if those values are still unchanged. So it's not about passing in arbitrary strings, arbitrary expressions. It's about passing in columns and columns only. But that's sysrow ETAG. Even if you never touch JSON duality views in 23C, sysrow ETAG is going to be a solution for all those concurrency problems that you had to write your code yourself for in times gone by. So as I said, you are going to absolutely love ETAG. So things to remember, it's not just JSON duality, and it's most columns you put into the function, not XML types. I've tried some of the spatial data types as well, like SGeometry and stuff. They don't work. But the vast majority of standard, what I would call simple data types, but it includes clob and blob, will all work. But remember, it's only for columns. It's not for expressions. But yeah, ETAG comes in 23C, removes the need for last updated timestamps, removes the need for row versions and stuff like that. Just a really nice, simple function to handle those concurrency demands that you have in modern applications. Okay. Number 3, how are we going for time? We'll get through a good chunk of them tonight, hopefully. Partition tablespaces. Here's the question that came in. We use interval partitioning to avoid needing to pre-allocate partitions in our data warehouse. That's a very sensible thing to do. However, we would like to set which tablespace a partition will go into when it is created. You can't do that until the partition is already there, sort of a catch-22 chicken and egg situation. Do we have to use alter table move to actually get it to do? And I would say the answer is loosely no, but there's a couple of scenarios we need to cover here, but I'll hopefully give you some solutions as to how you can perhaps work around this. It's sort of a bit of a hybrid because ideally interval partitions was to avoid having to pre-allocate partitions, but we can use effectively a simple pre-allocation mechanism here, but still take advantage of intervals. So it's a sort of a hybrid approach, and we'll do it with a demo. So I'm going to create a simple table here called T. I'm just doing partition by range. And the key thing is on line 6 here, you can see it's table space users, and we've got a couple of partitions, P1 and P2. So if we look at user tab partitions, we can see what's happened. Because we nominated a default overriding table space of users, the two partitions both went into the users table space. Nothing too complicated there. If I insert a brand new row, this will obviously allocate a brand new partition. You can see sys P230905, and that has also gone into the users table space because there's no other table space information in there. The question is, what if I actually want to have that go into a different table space? Well, one of the cool things you can do is even if you roll back a transaction that created a new partition, then that partition will not be rolled back as well. Partitions are created with a recursive effectively transaction. So rolling back leaves that partition in place. So you could, if you wanted to, insert a new partition, insert a value into a new partition, which creates the partition, and then just do alter table move. I'm just using a double ampersand there because I'm remembering what the last partition is just to make sure my script runs there. But you could obviously hard code this by querying the data dictionary. But in this case, I'm saying, well, I actually want that new partition, even though I know it's empty because I rolled back the insert. I'd like it to go into a table space, in this case called askTom, so I could move it. That's not going to cost me anything because the partition is empty. My indexes, etc., are going to be left unaltered. So that's one way of doing it. That's probably what our customer is currently doing, effectively waiting for a partition to be created and then moving it. My point here is you could actually deliberately do this in advance. Insert a row to force create the partition, roll that transaction back, and then do the alter table move, knowing that the partition is empty, therefore there's not going to be any expensive data movement. That's one way of doing it. Another way of doing it without actually going ahead and inserting a row, because if you insert a row, you need to know what all the values are and need to know what particular values are to actually make sure the right partition is created. Locking a non-existent partition in an interval partition table will also create that partition. So in this case, I've said, I want to lock the partition for the value of 550. Now, there is no row in that, there is no partition yet for the row value of 550, the partition key value of 550. But the database will go ahead and create that partition so you could lock it. So if I look at that, you can see it's gone ahead and created partition 23906. Once again, it's gone back into the default partition. Let me try that again in English. Once again, it's gone back into the default table space of users. But because I've simply locked that partition, there's obviously no rows in there at all. I can simply once again move it to the partition of choice, in this case, large TS. And you can see now it's moved that fourth partition into the large table space. This is perhaps a similar, but a little bit more easy to code up facility. I don't need to do an insert. I simply lock a partition that doesn't yet exist. The database instantiates that. I know it's there. I know it's empty. I can move it to where I want to go. The question is, can I avoid this move concept? Can I effectively nominate what the table space is going to be before I actually go create that partition? So let's explore again. Let me drop the table and start again from scratch, just with the two partitions, both in the table space called users. One of the commands that's tucked away in the documentation is you can actually modify what we call the default attributes for a partitioned table. And the syntax looks like this: alter table T, modify default attributes. And one of those default attributes is the default table space for all partitions created after the current moment in time that you do not explicitly nominate a table space for. So now that I've said from now on all partitions must go into askTom, I can do my familiar way of lock a table space, change the table space back to what it was before. So I've gone change it to askTom, lock the partition that doesn't exist yet, therefore creating it, and then immediately set the defaults back to users, and there's my new table space in the askTom table. There's my new partition in the askTom table space. So as you can see, that's one way of doing it now, such that I didn't have to do an alter table move at the end. And you can imagine those three commands, flick the table space, lock a partition, flick it back to the default, is something that could be done in virtually zero time. So the likelihood of other transactions going on, picking up a partition at the same time is very, very low. So you're insulated against other partitions being created at the same time. And obviously this is something you could actually use to, for example, if I've got today's partitions all created, I could probably create maybe a week's partitions in advance to make sure they go in the right table spaces. You could perhaps argue that, well, now I'm just back to a non-interval partition strategy anyway, but at least this way, you're not having to worry about ranges and calculating ranges, etc. You're just basically worrying about making sure you've got a few partitions created in advance. So I'd argue it's perhaps still a little bit easier. Now the question is, if I'm doing alter table, like alter table modify defaults, well, that's DDL. Is that going to be a problem if over in other sessions, my partition table is actively being worked on? Let's face it, partition tables typically are for big tables where you can have a lot of activity going on in other sessions. So let's explore that. So I'm going to insert a row. So I've got an active transaction on my table called T. And let's go back and repeat that same exercise on my table. I'm going to basically try create a partition and put it into a different table space by using alter table modifier defaults. As we can see, this particular alter doesn't need to lock the table. Even though we always used to think that alter table would need to lock the table, this one doesn't. So it doesn't care if there's active transactions on there. And we're simply modifying the defaults. We lock a brand new partition, so that's never going to be impacted by transactions because the partition doesn't exist yet, and then we set back the default. That all worked fine, even though I had an active transaction on the table. So it's not going to be impacted by concurrency. And as you can see, I nominated the default as large TS, so this new partition I created went into large TS. And if I go back to session 2, nothing changed there, I can commit and that's all done. So that'll work, so you're not going to be interrupted by concurrency as well. Now I did say there were 2 scenarios we had to cover. There's a different mechanism people can also use when they come to allocating table spaces for partition tables. And that's this syntax. They're using an interval, but they're also using this, the store in clause. And people use this when they expect their tables are going to be so big that each partition needs to go into separate table spaces and they don't want to explicitly nominate it. So in this case, I'm saying that as I create partitions, I want a partition to go into large TS. The next one goes into askTom, the next one goes into users, the next one goes into large TS. We simply cycle around this list of provided table spaces. Now, one thing that's important to realize is this is effectively bound to the interval clause, not the actual table itself. So what happens is, even though I've created 4 partitions here, P1 through P4, notice they all go into the user's table space. Because I created them at table creation time, they obeyed this clause here. What is the default table space for partitions that I nominate at creation time? They go into the user's table space. It's only for partitions I create as I now go on with the interval system that actually will now obey that store in clause. So if I go lock a whole stack of new partitions, partition for 560, 650, etc., then you can see this round robining now starts to take place. We had askTom, then users, then large TS, then askTom, then users, etc. What if for this scenario, I also want to now have some explicit control as to where the next partition would go into? I want to, for example, maybe have an exception to that store in case. Well, it's not a case then of modifying default attributes. That doesn't do anything. If you try and modify the default attributes to askTom, create a whole bunch of new partitions, guess what? They still do the round robining. They have ignored the default attributes because that's only for partitions that have been created explicitly, not through the interval system. It's a slightly different clause. It's this. It's alter table T, set the store in clause. Once again, one of those things tucked away in the documentation for alter table somewhere that's often overlooked. So if I want to nominate a particular partition, a particular table space, I would simply set store into being a single table space, then go pre-create my interval partitions as before. And as you can see, they've all been created in the nominated table space, askTom. And then I would nominate it, set it back to the default of whatever round robin system I wanted. I didn't do it here, but that's the end of the demo. So as we can see, there were 2 scenarios to cover. One is whether you want to manipulate the default attributes for the table space for a partition table, or whether you're using the store in clause for round robining. You can also modify that as well if you want to have control over which table space the next partition will go into. Now, one of the things that is cool, there is an outstanding enhancement request. I don't think it'll make version 23 of the database, but there's an enhancement request which is there should be, for example, some notification or triggering mechanism that you can be told when a new partition is about to be added. So what happens is, we currently have things like a logon trigger, or we have server error triggers. There is an enhancement request to have a database event trigger fire when a interval partition is created. Questions come in here. What happens if segment creation is deferred? In this case, when you do a lock or an insert, it doesn't really matter to the database. It says you are now demanding that partition be created. So in my database here, let's bring up so parameter, it's a segment. Yep. So in this database, you can see, Peter, that deferred segment creation is actually in place. But when you do an insert and a rollback, or you do a lock partition, effectively that partition will be instantiated. They'll actually become empty segments in the database. So yeah, excellent question. Okay, interesting one that came in from a customer. They're going from a 4K to an 8K block size. Here's the question that came in. We are migrating to autonomous, but our existing database is using a 4K block size, which in itself makes it pretty interesting. Very, very few databases have a non-8K block size nowadays. Autonomous is always 8K. In fact, pretty much every database nowadays you create is 8K by default. Will there be any performance implications of the larger block size? And there's a few things I want to talk about here. Unfortunately, this one will probably take up a fair bit of time. There's a few things I want to talk about here. That is the index block size performance myth, the table block size performance myth, and then why you still need to be very careful if you're changing the block size of your database. So let's cover those in turn. The index block size performance myth. And most of this is, I could argue this is my fault, but also a lot of people out in the community. When we're drawing indexes, this is how we sort of draw them, isn't it? We say, okay, yeah, an index is a B tree. It sort of has this, tree-like structure. There's my best PowerPoint art there in terms of drawing a B tree index. And as the index gets larger, it increases in level. It always stays balanced. The number of nodes is always balanced, but you can see we went from effectively 3 levels here, and then as we added more and more rows, it went to 4 levels. And this is sort of the idea we have when we look at the levels of an index. And then therefore, what's the cost of obtaining data from an index? Well, you start at the root block, you go to the branch block, the next branch block, and eventually you get to the leaf blocks to find your data. So the number of IOs for a primary key lookup is generally going to be the number of levels you have to descend. And for a non-unique index, you then scan across the leaf blocks. But it's always that little bit of navigation at the start. Therefore, the theory is if I could have an index which was smaller and more compact in levels, then that would make it a better index. There would be only 1, 2 navigations before you get down to the leaf block. It seems, intuitive that effectively, as indexes get to these silly levels, then basically if you could get smaller levels, then that would be better. Therefore, people say, yes, that's why you should rebuild your indexes all the time, or you should always use a larger index block size to compact those levels down. The problem here is simple. They are terrible pictures. It's as simple as that. Indexes don't look like this in an Oracle database. Yes, they are a tree, and yes, they start at the top and expand outwards, but they don't expand outwards like that. They expand out more like this. You start off with a root block, and then as you need to add rows, you end up with like this. You end up with incredibly huge amounts of leaf blocks along the bottom until they fill up and need to become branch blocks. And when they become branch blocks, you end up with ridiculous amounts of leaf blocks. So the concept of an index looking like this sort of structure like this triangular structure, is a myth. It looks much more like if you took that and made it almost level. They are incredibly wide and very, very short. They're incredibly broad. That's why indexes are so efficient at data retrieval. And as a result, the concept of, oh yes, I'll have an index with level of 12, and if I rebuild it, it'll have 11 of 5, is just a myth. It's almost never the case that any kind of operation on an index will change its level, except for, effectively big, giant jumps in the data. And let's have a look at that, for example, just to prove the point, if I can spell. So I will do this with both a 4K and an 8K block size, just to show that the subtle differences here, but the overriding premise is the same. That is that indexes are incredibly flat. I've created a little 4K cache here, so you need a DB cache for 4K block size before you can put effectively a 4K block size table in there. I pre-created a 4K block size table space because this is an 8K database, and here's a little tab 4K block size. I've made it exclusively just an index. It's organized an index. It doesn't have a heap table. It's just an index structure, but it's gone into my 4K block size table space. If I insert a single row in there and then validate the index, you can see it has a height of 1. It is just a single block. It's a root block, which happens to be both the root block, the branch block, and the leaf block. It's just a single row in the index. It only has one particular block and a height of 1. If I insert 500 more rows, guess what? It's still just a 1 height index. in this 4K block size, it's only when I get to the 501st row that has filled up that one block, and now it's jumped into two. It's now got a root block, which is both a branch block and a root block and a single leaf block. So we've finally jumped up one level. This is when it jumps. So you get to 500 rows, you jump to level 2. The question is, when do we get to level 3? Well, let's put another 157,000 rows in there. It's still at height 2. It hasn't changed in level. Put one more row in there, 157,793 rows, and we finally get to level 3. So now we're at level 3. How much does it take to get to level 4? Well, I'll spare you the time it took because I wrote this little routine that simply inserted 1,000,000 rows at a time and then checked to see what the level was. And eventually, I had to get to 42 million rows before I got to level 4. I didn't even try to go beyond that, but you have to get to a very, very large structure. 42 million rows all spread across to get a level of 4, including just the root block at the top. So in reality, we would say the B level is 3, the height is 4. But yeah, it's just ridiculous how many rows you squeeze. And this is a 4K block size. These are these 4 smaller blocks. Let's repeat the same thing with an 8K block size. Obviously, you can fit more K in an 8K block. Once again, one row in there, the index height is 1. Put in 1,000 rows, and the index height is still 1. It's only when I put the 1,013th row in there, or 1,014th row in there, that the height goes to 2. How do I get to level 3? Well, another 650,000 rows. It's still at level 2. Add one more row, it gets to level 3. So now, to get to level 3, I'm at the 650,000 row mark. If we start comparing that to the 4K block size, the only reason this would become an issue is, well, what if I've got these tables that just happen to be between 150,000 rows and 650,000 rows, and they stay at that size, then there'll be this discrepancy of 1 for an index lookup between the two. I'd imagine that's fairly niche, because tables with 150,000 rows generally grow, and they're going to grow larger. It's sort of it's a nonsense to say that that's going to be a big differentiating factor. How do I get to level 4 on an 8K block size? Well, for a start, I had to put 150 million rows in there, which I'll spare that I didn't do that. And then I ran that same loop starting at the 150 million mark. And funnily enough, it was actually right at I was actually inserting them in batches of 2 million at a time. So somewhere between 198 million rows and 200 million rows, the index for an 8K block size jumped up one level. And the question is, really? Like you can imagine, that's just incredibly flat and broad. The concept of your index is growing to silly numbers of levels and therefore having an I/O impact is just a myth. Let's go back to my slides. Now, to give you an idea, I plotted those 8K block sizes, but I plotted them on an algorithmic scale. So you can see we went to level 1 at effectively a B level of 1, which means a height of 2 at 1,000 rows. I've done this logarithmically. Level 3 at, was it 100, just over about 600,000 rows, wasn't it? Level 3 at 200 million rows. Doing a trend line, there was no way I was going to try actually populate data to level 4. Doing a trend line gave me that this would be at about 120 billion rows is when I get to the next index level. That shows you just how incredibly flat these indexes are and how unlucky you would have to be to find some particular scenario where you're permanently stuck, where a 4K level is doing one more I/O than an 8K level, right, before they both jumped into the same level anyway. So some excellent reading on index block size versus the height and why it's not going to be an issue in terms of performance on Richard Foote's blog. That's part 1. Let's talk about now the table block size performance myth. People think, if I'm going to a 4K to an 8K block size, there's going to be this dramatic change in performance because 4K, I read 4K blocks at a time. So to read a certain amount of data, I've got to read, 8 IOs there. But if I did it in 8K, it would be twice as efficient because I'm reading twice as much data each time. Therefore, 8K is going to be dramatically faster. Therefore, there's going to be a significant performance difference between 4K and 8K. Let's have a look at that as well. Once again, I'll create my 4K table in a 4K block size. I'll create an 8K table in an 8K block size. That's just going in the user's table space, which is 8K. And let's flush out the buffer cache and turn on a trace file so we can actually see what the I/O cost is to simple queries to these two tables. Each one's a copy of DBA objects. So I'm turn on trace file with weights equals true so I can catch the I/Os. I query my 8K table, and because I've turned on trace file, unfortunately with Windows you have to disconnect and reconnect, but as we've seen in previous office hours sessions, what I can do is I can use an external table to actually query the trace file direct from the database. And I'm just looking for anything which had a DB file scattered read, which is a top to bottom scan of the table. What do we get? This. Because of the size of the extents, we have some interesting things here. The first thing is the first batch of 16 extents are 64K extents. So we get anywhere between 5K to 8K reads, depending on what's floating around in the buffer cache, etc. And then once the extents jump to a megabyte in size, we actually jump to these sort of 126 to 128 size IOs. Keep an eye on how much they took. Each one took about, on this machine, about 2 to 3 milliseconds. These are in microseconds these times. So I did 30 IOs to read my data, and when we got into the sort of the chunky parts, right, we were looking at about 2 to 3 milliseconds. Here's my 4K table. So once again, get the name of the trace file, flush the buffer cache, turn on trace, read my 4K table now. Let's have a look at the trace file. Same thing, external table, directly actually a trace file. We go, oh no, look, we did so many more IOs. Oh no, this is a disaster. But let's scroll back. The database is smart. For these 64K extents, it automatically jumped from 8 IOs at a time to 16 IOs or 16 blocks at a time. So it went ahead and read those 64K things in a single trip anyway. When we got up to the larger extents of a megabyte, well, we had to do more IOs because there's an upper limit of 128 blocks at a time. 128 times 4K gives you 512K reads. So we had to do more IOs to read the same megabyte extents. But the key thing here is modern disk systems are intelligent. Look at the elapsed time. It's about half. That's because disk systems do read ahead, etc. So even though I did more IOs, every single one of them was about half the time. And it doesn't take a rocket scientist to work out that if I did 10 IOs at 3 milliseconds, that's the same as 20 IOs at 1.5 milliseconds. The overall time is about the same. So what we have here is that we've shown that index level is not going to be an issue really when it comes to different block sizes. Table scans is not really going to be an issue when it comes to different block sizes. However, having said all of that, the fact that the block size won't change the underlying database physical performance, what will change is because you have different metrics, different number of rows per block, different number of blocks, etc., the optimizer will come up with different decisions. And that is something you do have to take into account when migrating to a new block size. Let's do a little demo of that. So just to prove why this is an important thing when you change block sizes, that you will need to do some performance analysis. I'll take my two existing tables, which are just copies of DBA objects, and whack an index on the owner column, both on the 4K and on the 8K block size tables. Let's do some execution plans now. Here's a query. Go get some rows from the 8K table where the owner was greater than T. I just picked a value out of there. The optimizer says the cost was 484. If I force it to do a full table scan, we can see why it chose an index, because the full table scan comes in at a cost of 492. That's more expensive than 484, and that's why the optimizer would choose an index by default. Let's have a look at the 4K block size. Same scenario. It thinks the cost is 119 using the index, whereas a full table scan is 817. So in this case, it's still the same. No other things changed. Both the 8K block size table and the 4K block size table opted for an index range scan on this query. But the fact that the numbers were so dramatically different means that's perhaps not a guarantee that this will be the case in all circumstances. And if we simply modify this query slightly, I've changed the T's to the S's. In the 8K table, the cost is $4.92 as we saw. It thinks that's the better option. It's better than using an index. In the 4K table, it still thinks the index is better. So putting aside the rest of the previous demo, you can see if I took this query, where are we? If I took this query as it was in my 4K block size table database, it would say, yep, for this query, I should use an index. I migrate this table to an 8K block size database, the query is unaltered, it flips to a table access full. Now, that might perform better than an index range scan, it might perform worse. The key thing is there, the execution plans change. So the message there is the standard rules apply. If you're making a structural change to your database, just like adding indexes, just like dropping indexes, in this case, you're changing the block size, the performance characteristics of the database at a physical level won't change. Table scans will run roughly the same. Index, capacity and density will run roughly the same. There'll be slight differences due to block overheads. But performance may change because execution plans may change, because the numbers are different. Therefore, it's important to test. Okay, so what about table compression and different block sizes? Okay, so that's an excellent question, Peter, and really that's just a special case of the equivalent of the fact that the cost of a block header is different across different block sizes. Every block has about 120 Ks of overhead in it, for header information. That's a greater percentage of a block in a 4K block than it would be in an 8K block. So you would get less rows per block. If you took it, let me start again. A single 8K block might consume more than 2 4K blocks for the same data, simply due to the overhead of block. Compression comes in the same, right? Because compression is done at a block level, you might get more duplicated values in an 8K block than you would in a 4K block. So the distribution of data may be slightly different. But all those things really aren't going to change dramatically the performance characteristics. What is really going to change is the execution plans, because they're the things that most dramatically skew performance. Things like compression and stuff, you'll get better compression in an 8K block, but what's going to happen is that might give you a 5% performance benefit on an 8K block, maybe a 10%, etc. What will give you those classic, it ran in an hour today, now it runs in 3 seconds, or it ran in 5 seconds, now it runs in 4 hours, is when your execution plans have that dramatic jump in change. And they're the things that are really critical when it comes to changing the block size of your database. But excellent point there. If not exists, do we have time for this? What do we got? We've got 2 minutes left. Yeah, I think we might be pushing it. We're going to have to do that, unfortunately. I knew that last one was going to take a long time to run. But not trying. Let me kill that share. As always, thank you very much for your time on office hours. I hope you got some value out of that content. We'll touch on the other ones, obviously, in next month's office hours, etc. In the meantime, if you have any questions about that, please hit me up on Twitter. I always enjoy interactive flow. Thank you for your questions today, and obviously thank you for your time and attendance. Next month is what? Next month is May, so I'll be back in May for another office hours session. I'll try and make that so it doesn't overlap with Apex Connect, which is obviously in May as well, and such that we have the ability for you to attend this and still attend their various conferences, because I keep saying make sure you go to those user group events. But once again, thanks for your time. I hope you enjoyed this session, and the video will be up shortly. But as always, I'll see you next month on office hours, and until then, bye for now, everybody.